One single mistake here, and tons of wood become worthless instantly. And it can happen in seconds. This entire log will be completely gone in under 60 seconds, and still, not a single piece is wasted. What happens here looks brutal, but it's controlled down to the millimeter. Massive machines peel solid logs into paper-thin layers, rebuild them, and turn them into something stronger than it looks. This is where everything is decided, because this process allows zero mistakes. So how do these factories produce perfect plywood every single day? No breaks, no margin for error. And what really happens inside the largest sawmills in the world when everything runs at maximum efficiency? This is just the beginning. Because before the first machine even starts, the most important decision has already been made. Not every tree even makes it to the first machine. This is where it's decided for the first time whether a log becomes a high-quality product or pure waste. In massive forest areas, specific types of trees are selected and cut down. Usually fast-growing species like pine or birch. They provide exactly the properties needed later. But cutting the tree is just the beginning. From this point on, time is critical. Freshly cut wood starts changing immediately. It loses moisture, cracks internally, starts to warp. This is where it becomes clear just how important timing really is. The logs are transported as fast as possible, often straight to huge sawmills running 24/7. Once they arrive, the first real selection begins. Every log is checked for internal stress, curvature, and hidden damage. Some facilities even use advanced scanning systems that can look inside the log before it's processed. They detect weak points, density differences, and hidden cracks that aren't visible from the outside. Because what looks perfect on the surface can already be unstable inside. And if that goes unnoticed, the problem doesn't disappear. It moves forward into every single step that follows. This is where small defects turn into expensive failures later in the process. Even the smallest imperfections determine whether the material is usable or rejected immediately. But even perfect logs aren't ready yet. What happens next feels completely wrong at first. The wood isn't dried, it's softened. In massive water basins or under hot steam, the logs are treated for hours. Why would you intentionally make wood softer? Because this step decides whether it can later be peeled into thin layers or tear apart completely. This is where the preparation pays off for the first time. After hours, sometimes days, the log is ready. The bark is removed. The log is precisely aligned. Everything is set, because in the next step, solid wood becomes something completely different. This is the part most people have never seen. The log is locked in place and starts spinning. Then a massive blade cuts into the wood, and it doesn't stop. The entire log is peeled in one continuous motion. Meter after meter turns into a never-ending sheet of wood. What comes out looks almost unreal. One single log turns into meters of thin wooden layers within seconds. From this point on, there's no going back. One mistake, and the entire log is ruined. The layer is incredibly thin, fragile. Even small irregularities can tear it apart. And it happens more often than you'd think. Even tiny inconsistencies inside the wood can cause the sheet to suddenly rip. When that happens, the entire process has to stop. Time loss, material loss, cost. And that's exactly what these factories try to avoid. The machines operate with extreme precision. Every movement is calibrated. Every cut is controlled down to the millimeter. But even perfect technology can't control everything. Because wood is not uniform. Every log is different. And that's what makes this step so unpredictable. But even perfect layers aren't safe yet. From here on, things get critical. The fresh sheets have to be processed immediately. No pauses, no delays. Too much moisture, they warp. Too dry, they crack. Entire batches fail at this stage. And this is where it's decided if the material can even continue. A small mistake at this point can affect the entire board later. Often invisible, but with massive consequences. The usable layers move forward. And then something happens that changes everything. The grain direction is rotated, layer against layer, force against force. Each layer compensates for the weaknesses of the others. What looks simple is actually a highly controlled system. This is what gives plywood its strength. This is where the entire process starts to pay off. But before it becomes a finished board, one final step remains. And it decides everything. From this point on, it gets serious. The prepared layers are stacked, but not just placed on top of each other. Adhesive is applied between every single layer, and this step decides everything. Too little glue, the board won't hold. Too much, it becomes unstable and useless. There's no room for error. The layers are aligned with precision. Millimeters matter. Once the stack is complete, there's no turning back. Now comes the moment that defines the entire process. The stack is pushed into a massive press. Pressure, heat, time, all at once. Within minutes, enormous forces are applied. The adhesive reacts and permanently bonds the layers. At this moment, temperatures and pressure begin to permanently change the material. The layers don't just stick together, they become one solid structure. What used to be fragile, unstable sheets now behaves like a single, load-bearing material. This is where the strength is created. At this point, it becomes clear whether everything before was precise enough. Even small deviations in pressure or temperature can cause failure later. Not immediately, but later, when it's already in use. In houses, furniture, structures. That's what makes this step so dangerous. If everything goes right, something completely new is created. From fragile layers to a solid material. But even now, the process isn't finished. The boards are cut, sanded, and inspected. Every single one. Because even the smallest defects can cause major problems later. And many of these defects are only discovered when it's already too late. But one question remains. If a single mistake is enough to ruin everything, how many of these boards are out there, carrying weight, even though they should have failed? And many of these defects are only discovered when it's already too late. If a single detail decides whether a material holds or fails, how many of these boards are out there right now, carrying loads they were never meant to handle?